Welcome to this video. We are looking today how to use data tables. Data tables are related data. Should be simple, otherwise better use an object. The data table itself is always a struct construction. So you start with a struct and from there you create your data table. A struct here via blueprint new struct. You give it a name. It should start according to the naming convention with F. And here in the struct, you can add as many simple or also complex types, including other structs that you need here. So just an example, I select an int here, a string here, and here let's select another structure. Yeah, whatever I use here, doesn't matter. And that is how you build your base construct for your data table. You should give it some speaking names. You can comment on that. And then we save it. So we have our base struct as step one. Next step would be creating the table itself. Here under misc, we have a couple of data assets. One of them is the data table. First thing is you have to select your struct as a base for it. Here we use our test struct here. That's okay. And data table, I always start them with DT and then again some test naming. So if you open that table, you will see that you can, now it's empty, but you can add your rows. And for every row, you have here the row editor, the detail view, where you can fill exactly the data that we had here. And if you added another struct, it will be kind of flattened, so you see all the fields from the struct and can accordingly fill them out. Yeah, depending on the number or on the format of the data, the type, you will get different fields here just to select. If you go here in the data table details, one important thing is, what is the basis here? What struct do you have? Quite often you will strip it from client builds, and you also have the possibility to add a source file here for import export. Exporting is easy from the outside, right click, export as CSV and JSON. That is creating then one text file in your somewhere in your directory structure. Here I export as JSON test.dt, and if I open that here, let's do it just via that menu here, right click and open, and you will see here what the format needs to be. You see the struct very nice here that is broken up, and that is the format that you would need. In theory, you can create that however you want and just add it here. I will link to something showing it for periodic system elements and how to go from a G sheet, a Google sheet, into such a JSON with some exporting options. But here you can really enter what you want, and that would be the normal way to generate out of the data of a database or a sheet or whatever, and take this as an input for your struct to work. So let's save that. So now we should have two elements. We added it here. In our data table, this file is now our source file. So let's look for it. Here we say open. So now it's the source file as a basis. If I click re-import, let's go here to the data table itself, click re-import. And here on the lower right, you see successfully re-imported. Can also be, if it finds problems, it will try to re-import as much as possible. If it does not fit something, it will leave the columns empty. But it's quite error tolerant actually. Now we have a next row, the new row 2, where we have exactly the variables that we just filled in our text file and be done. What makes sense is always filling one row, exporting it, then you see exactly the structure that you would need. And here on the right, on the top right, you see what I promised. That is just a table with periodic system elements. And here I go through the work to kind of prepare it for a JSON export, then have some results with a JSON export, and finally export it all so that every single row would be one struct actually. So at the end of the preparation, we would have 99 different structs described here in these elements, and that is then what I could use as a basis to import that into a data table. Video below shows it. So data tables are nice for import export. They are not so nice if you want to do something with the data, like searching, for example. So you should not do that. If you need more elaborate data functionality, use a data table, a real one, a data table from a database like SQL or Graph or something else. So what we did here, we created from struct, we created data table. We looked a bit at options here in the editor. We can always here import, export, open the source and see really what is the connection between text files and this. You can actually also use in C++ CSV files or JSON files directly instead of a data table and use it as a data table. So at the end of the day, it's really a very, very simple way to deal with data, but really don't overdo it. If you have more complex operations, always use a real database and not a data table, an external one. So let's create a small actor and look how we would work with data tables in blueprints. So we have the actor here. Let's look at the event graph. It's empty at the moment. And what we want to do, we want now just connect to a data table and do some things with it, searching, iterating, and so on. First thing, I create a variable that is actually a data table. That will be the data table that I use here in this case. So meaning it's hard-coded here in our case. We could also do it via a soft reference and a string path, but let's start here. So it's empty for the moment. Let's look, for example, for our test database that we just created with these 2 rows. That is what we have here. So now we really go for, we connect to that database, we look if a data table, a data row is existing, and then we say yes or no. That's quite simple for the moment. So we take our variable with our data table, we just right click here and say, does data row exist? And let's say if it exists, we say yes, existing, and if not, we say no, not there. And let's have a look. We have here a couple of rows that we have. That was the wrong table. So we had, for example, this new row number 2. That was the one that we created via the JSON file. And from here we say, yeah, does it exist? Then we print something out. It exists. And if it does not exist, we say, yeah, does not exist. And yeah, let's try that already. So we have this actor, we put it into level, we have a begin play event, and then let's go. Yeah, and it seems to connect to the data table, looks for this row. If it exists, it says yes, it's existing. So that's the very simplest use case that you could get. What you will normally do, you actually will want to have maybe all table rows or one defined one, and for example, iterate on top of that. So first thing is we get the table row name so that we know all the rows, and then we iterate over these rows and getting that single line for each. So first thing, get table row names will give you an array of names, and taking that name array and just saying for each. Then you get your loop around it, and each array element is a name, and I could take the thing from the first iteration, getting this table row name and doing something with it. What it gives back again is our struct, because that is always the basis for our data table, meaning I could, for example, break this struct and see what it actually has in it. It does not know which kind of struct, so meaning it would, you could use every struct here, but if the wrong struct is coming, you will generate an error. I again break this struct variable that I had here, this ABC compression, whatever that is, and now I have really access to all the possible fields in this data table. So if the row was found, I would say again we print something out. Let's say the max number of bases, and that is what we then should see. If we check, that's a artifact going away here. If we check what kind of data we would expect, so here we have the max base that seems to be 2, and the other one seems to be 100. So I would expect if I now run the whole thing, you get here 2 and 1000, and yeah, be done. Let's look at C++, how to do it. Easiest thing to do is you use a soft path reference, because that will cache the access after the first access to it. Quite often you see this construction helper, but it is something that I think doesn't have caching, but definitely needs to be inside the constructor, so it's a bit less easier to use. So first we put that variable DataTable, then we create an f soft object path, then we try to resolve the object, and if that fails, we actually try to load the object. Loading is quite slow, that should only happen once. After that, after each usage, we just resolve the object and fill the data table with it. So target is really creating our data table variable and filling it with the right pointer to it. So first thing is we have a path variable here. The path is what you see here, and that is the reference that you get via right click. So it always starts with something like script engine, and then at the end you see your directory information. So right click on every object in your editor and you see the reference. So first thing, we try to cast something to the data table, but only if the resolve is working. We take this path. If it's not empty, then we can go that routine. If the first attempt did not work, then we have to load it. For all other cases, we just resolve it. If the data table is actually something that has some meaning, looking into the right data structure, then we can start using it, iterating it, or whatever. So same thing, let's create a small class. In our case here, that is a BA data loader, I call that class. So we have an actor there. And again, we put it into our level. This load data table is again on begin play. So let's try that. You see, here we have this warning, need to use slow load object to load data table. That was the first iteration. And that is exactly what we would expect, because the first time we use it, we actually have to do the slow. The second time we use it, it is already there. So we would just resolve the object and don't need this try load anymore, because that is quite slow. So we have a kind of caching mechanism that we can use here. You always see here this Pastebin that you can use to get this code. Other than that, I think it's quite straightforward. Looking at the variables here, one is this data table that I called connection data table. It has an edit anywhere and blueprint read write, meaning I can actually edit that in the editor and set it here. And then it would, only if it fails, we go to the back to this path. Looking here at my editor, going down here, you see this connection info, and that is the place where you can define the data table externally from the editor. No need to resolve to the path, but it's also an option. I want to show both here. So meaning in my logic here, if that is not set, it goes back to the path. Normally it would be set here, and then it just takes that reference. Good. Let's go next thing. Begin play. It will look only if this externally set variable is not valid, then it will actually take the path and load the data table from there. Other than that, it's already set, so we don't have to do that and can jump to the next one. Now I set it and you see, already the data table is valid and loaded, so we can continue from here. So let's stop that again and let's go to the next one. Quite often you want to iterate over a table. So here in our case, we try to use this lambda function. We have different options here, so we use for each and a couple of things that we have to provide. This is this here, so on reload is the routine. For each row we want to do something. First thing is we have to give it the structure, that is the basis of the data table. Then we have some text that is more for logging, and then we have this number expression with a capture list, with an argument list and the function itself. The capture list, that is define what variables from the outside of the lambda will be available. In this case, it's the whole object. Then the argument list, these are the arguments that I need. In this case here, I just have a key and the value. And then we have the lambda itself. In our case, we have this connection map, that's a T map, adding this key value to it. So what I essentially do is converting the data table into a map. And in one case here, I go into the value as active connection and look if what the variable is actually, what the value of that variable is. You see here the connection map, that is just a T map with a name and a struct, the struct f connection info again, that we use here all the time, and that is what is filled from the regarding data table. So the on reload thing that is called always when a table is changing, I'll come to that a bit later. When we do here, when we start it, you see here the connection map is starting to get filled. Here in my data table I have 3-4 lines with different authentications for local Neo4j, and that is exactly what happens. So every row will be processed for each row, and the T map will be added and extended here. Next thing what we could do, we can find the row. Finding is on the data table only on the row name, nothing more. Meaning you cannot really access the values. That's one of the big disadvantages of a data table. You can of course iterate over it, but that's quite time consuming depending on the size of the table. So here we have the structure. We say, okay, find row. We again need to say what kind of structure it is. We have an fname parameter. We have some context, that is again a string for logging. And we have this true false, this boolean, that is warning if a row is missing or not. That is quite straightforward, I would say. Meaning we try to fill this variable, this con variable. If that is valid, we can log something out, for example. So let's try it. Here, my row name is noauth. Then you see here, yeah, con was filled. It has this struct behind it, and that is exactly what we would expect according to our data table. That is here, this row that was found here. Let's filter here for BA data loader, and that is exactly here what you want to see, the URL. On data table change will be fired every time the data table is updated. What we essentially do, we point it to a function that will be called the moment you get an update on the table. And yeah, let's have a look how that works. What we do here is we have again our database, data table here, the connection DT. We validated it, we loaded, so it should be filled at this point. Now we want to add this function every time the table is changed. So on data table changed, we can add actually different things. We could again add a lambda. We use here the add u object, pointing to one of the u object that we have, and give it one of our functions that we have. The object in this case is this, so it's just the same class, and it points to the onReload function that we have down here, and that is exactly the function that we used for iterating over the row. So what we would expect is each time the table has been changed, it would automatically reload and refill our connection map, for example. So let's try that out. What we expect here is again this couple of rows. Now I start changing it. So let's say here the true goes to false, and immediately we have our breakpoint here, and it will reload automatically what we have here as information in the data table. And we should also see some changes here in the connection map. So let's move on here. Okay, moving on. So now let's try again. We change here, for example, the name, put something in there and return. And again, we are here on the reload. So it's quite easy. Really, every time the data table will update, we will also update here whatever game logic we have. So summing it up, we have some definitions, we have some helpful links. We looked at Blueprint and C++, how to do basic things with the table. It's kind of similar what we do. It's of course a bit faster in C++, but you have the same functionality outside of the onChange event. So that is not that easy to do. You need a bit more to do that with the Blueprint. Other than that, you have the typical things: loading table, iterating over table, finding a row, but not only finding the name. That's important. So you cannot find a value with that approach. And then on data table change, we do something. If you really want to work with the data, you should not leave it in the data table, simply because it's not really enough to be able to find the row name. So that is something that we might need to improve, and that might be a topic for the next one. I hope this helps, and thank you very much. See you.